Ah, nuts. Hello Internet, my name is Quinn and this is Blondihacks. I've got this old model boiler that I built and it's a pot boiler and it's electric and it's not very efficient and the outside gets really hot, dangerous to the touch, and it doesn't look great because the silver soldering on it is not very awesome. So we can solve all of those problems in one fell swoop with a traditional practice called lagging. This involves insulating the outside of the boiler with mahogany wood, and it'll improve the appearance, the efficiency, and the safety of this thing all at once. So let's go. Conveniently, the boiler is already stripped from pressure testing, so I don't need to do that, but I do need to do something about these brackets. Remember I showed a while back that one of them broke, and they're just simple folded brass strips that gave out under the load there. So I need to do something better here before I can do the lagging, and well, I came up with this rather elaborate solution involving a machined ring with little rabbets that'll hold the lagging and tapered split pins that'll compress as they're tightened into the legs, and I was going to have to get a tube roller and make large round pieces to machine, and it was going to be this whole big project. And then I stopped and thought, I'm planning to make more boilers, and this boiler structurally is not awesome anyway, and I don't think I want to spend a bunch more time improving it. So I've decided to relegate this to a bench testing boiler, and instead I'm going to do the simplest, quickest fix here on these support straps. So to do that, I'm going to reinstall it on the stand here temporarily so that I can measure the gap that needs to exist down below there between the straps. What I'm going to do is I'm going to replace the folded tabs with some solid blocks, because you can see they gave out really just from stress fractures. I had cold worked these straps. I didn't anneal them before making those sharp bends, and so there were probably micro fractures in there, and then the thermal expansion of the boiler caused one of them to fail. So I've got this piece of square brass bar here, and I'm just going to cut some little chunks off, machine them square, and I'm going to make 4 little blocks to go on the ends of those straps. I'm going through the meticulous process of squaring up the stock using the brass wire and tapping it in and putting the machined face on the fixed jaw and all that jazz. If you've seen my Mill Skills series on squaring up stock, then you know why I'm doing all this. And you might think this is totally unnecessary for these parts, and it is, but this is just the kind of time where I like to practice the precision work here, because this is the time when it doesn't matter, so if I make a mistake, it won't hurt the part and allows me to get better at making precision parts for when it does matter. I need to cut this long piece into 4 little pieces, and an easy way to do that while accounting for saw curve is just to split the blocks twice, right in the middle, and then you guarantee that the error and the saw curve is distributed evenly among all 4 pieces, and none of them will end up too short. If you try to measure from one end and cut them off one by one, then you tend to end up with the piece on the end being a little too short. So then I squared up the ends of each block and brought them down to final width. And again, since this was an exercise in precision practice, I did some inspection here to see how well I did, and pretty good. I'm within 1 thou on the dimensions on the short sides, and then on overall length, I'm also within 1 thou there. So always good to keep those precision skills sharp for when it's really going to matter. Now I'm going to throw precision away and just eyeball some holes in the center of each of these blocks, but I am going to at least get them all the same. So I'm going to set one up here, and I'm going to put an end stop on it, and then I'm going to eyeball the center drill on my marks there. And so however good this one is, at least all 4 of them will be the same because I can use the end stop. So I center drill 1, with the end stop, it's very quick to center drill all 4, and I know that parallel's crooked. Look, it doesn't matter for these parts. Save your comments. After the center drilling, then 2 of them get clearance drilled for the bolts, and 2 of them get tap drill size for the bolts. And then 2 of them get tapped for the bolts. This is my spring-loaded tap follower, which I made in a previous video. If you're interested, go look on my playlists for that project. Now I'm going to clean up all the parts with acetone, and I'm looking to silver solder these to the strips. So I'm going to cut off the old tabs there, even though only one of the 3 had actually failed. If one of them failed, the other 3 were probably gonna. So sawed them off and then cleaned up those sharp edges with a file. And then I cleaned everything up as best I can with Scotch-Brite and acetone. Make sure everything's spotlessly clean, very important for silver soldering. And then on goes the flux. I'm using my ceramic jeweler's fixture plate here. This is a great little tool for silver soldering small parts and holding them in place like this. And I'm using kind of a weighted finger on there, kind of like a miniature version of a welding finger. This is just pieces of scrap that I found. And away we go with the torch. Much like welding, silver soldering is all about heat control, and the challenge with an operation like this is I've got a high mass part and I'm trying to bond it to a very, very low mass part. So I'm trying to focus all the heat on the block and basically not touch the strap at all as best I can there. And this went very well. Once that's cooled to black, then I dunk it in water to cool it off the rest of the way, and that also helps keep the scale and other crud from sticking to it. As long as you don't quench it while it's still red hot, then you won't hurt the silver solder doing that. A frightful mess it is after that, but a quick hit with the Scotch-Brite wheel and it looks all shiny and nice. Now you can also go in with a file and clean up the little remnants of silver solder and stuff in the corners there if you want, but I didn't bother because these are workaday parts that are probably never going to be seen again, and they're going to tarnish immediately anyway. So, little test fit here. One bolt goes in, and that looks like it's going to work really well. So that tightened up nicely, and that is going to be much, much stronger than those old bended tabs were. So I feel really good about that repair. I did the other end the same way, and now it's time for lagging. The traditional method for lagging is to put mahogany wood on the boiler. So I bought some of that from a craft supplier here. I'll just set that on there. Okay, good. So, should be much more thermally efficient now. Well, initial testing showed that didn't help at all, so I think what I'm going to need to do is actually put it all around the boiler. That's not in the instructions anywhere. I've seen a few different methods for doing this, but this is the one that I thought I would try because it looked like it would work well. I wrapped some rubber bands around the boiler and tied them in little knots. Of course, the ends of the boiler in this case are not accessible because of the way the legs and the electrical box are. And then you just start sliding the mahogany strips in there. Now you can make these mahogany strips yourself if you have the right woodworking tools for it. I don't, so you can just buy them cut like this. These are the 1/16 thick strips. And they are a little expensive. They're about $1 a piece, these strips. So, don't buy any more than you need. This stuff is surprisingly challenging to cut. A model railroader hobby saw didn't do very much good, so side cutters seem to work much better. And then I used 80 grit sandpaper to sand off the pinch marks from the cutter there. Then it's just a matter of scribing the outlines of all of the components and carefully cutting and sanding and filing your way around them, which is just as tedious as it sounds. This is definitely a job that requires some patience, but it's kind of soothing if you like this sort of thing. It's very much like doing interior trim work in a remodel. I started with the top, and I'm glad I did because it's kind of the worst part, so get that out of the way first. And it also helps serve as kind of the guideline for the rest of the strips to make sure that they all end up parallel to the boiler when you're done. If things start getting crooked, then much like laying hardwood flooring, you're going to be very, very crooked by the time you get to the other side of the room. So once I had these baseline pieces at the top, then I taped everything together to hold them in place. And then that acted as my straight edges effectively for the rest of the work. And this actually worked really well. Just make sure that that's straight and square to the boiler before I go any further. Once you're below the fittings, of course, it goes much quicker. Now, when it came to the leg brackets, I had a decision to make. I decided to go around and behind them and then just pick a point where it looked like the brackets should transition from behind to in front of the wood. And I did it that way because the brackets had already been made precisely to fit directly around the copper shell, and there really wasn't going to be a practical way to make them bigger to go around the wood. It's pretty traditional for the boiler support brackets to go on the outside of the lagging, but this seemed like a good solution here, so I just fitted pieces around all the brackets and then went from behind to above at the right moment there, as you can see. And I actually kind of like the way that this ended up looking in the end. Now it's time for the boiler banding, which are thin brass strips that hold the wood in place. Now, here's the thing about a new hobby. You don't know what you don't know. And one of the things that I didn't know is that you can buy boiler banding. It comes in long brass coils, various different widths. You just cut it to length, bend little tabs, put a bolt through it, and you're done. I just didn't even know to look for such a product. How did I learn this product exists? Well, my boiler bands were basically complete, and I shared them with my generous patrons over on Patreon, and one of them said, "You know, you can just buy boiler banding, right?" And I picked up my jaw from the floor, and I was like, "Gosh, everybody knows that. I just wanted to do it this way because reasons." So I went and made these boiler bands myself from scratch the very, very hard way. Now, bear with me here because I think there's still useful techniques to be learned in what I did, and the way that I did it might be useful for other applications later, so don't get hung up on the fact that this is a really hard way to make boiler bands. Just know that if you're going to do this, you can buy boiler banding, and if I had known that, I definitely would. So, imagine a world, if you will, where boiler banding does not exist, and you have to come up with thin brass strips yourself, and all you have access to are these hobby store crappy brass strips that are only 12 inches long and only come in 1-inch widths, because around here, that's what I can buy. How would I go about making boiler bands from this stuff? This would be a straightforward job if I had proper sheet metal tools. I do not have proper sheet metal tools, nor do I have space for them. So here is a technique that I have used before to work with sheet metal and to cut long, thin parts that has worked well for me, and that's to do it on the mill. Now, it's not fast, but in a pinch, it does work, especially if you don't have proper sheet metal tools. This does a nice job. So the technique is basically just that you clamp the material down with a long, thin piece there for support, and you line it up on a T-slot, and then you just run down the length of it with a small milling cutter, and you have sheet metal parts of any size and shape that you need. So this is my typical setup for doing this. Now, I wanted to use a 1/16 end mill this time to get the saw kerf as small as possible, but this won't clear these big heavy clamps here with the small end mill. Previously, I've done this with an 1/8 end mill, which will clear. So that wasn't going to work. So I brought in a secret weapon, recent donation to the channel from the awesome folks at Dayton CNC. This is also sold through Little Machine Shop. Hashtag semi-sponsored, they sent me this for free, but oh my gosh, this is just a beautiful fixture plate. Just the thing for hobbyists. It's so nice. It comes with these machined pins that you can use a parallel to offset the work to exactly where you need. And then it also comes with this beautiful set of machined little clamps that are perfectly scaled for model engineering. Honest review here, this thing, it's beautiful and I absolutely love it. And it's the perfect thing for making these long, thin cuts on this sheet metal. All right, spin it up, start my cut, and snap. Yeah, broke that end mill immediately. So let's talk about what happened here because there's a lot to be learned. It's hard to know exactly why it broke, but there's a few likely causes. One, this end mill is probably running too slow. My mill caps out at 2500 RPM, which is about a fifth as fast as a 1/16 end mill is supposed to be running. Problem number two is that there is some vibration in that sheet metal at the end, so it likely was binding up on the end mill, especially because a right-hand helix end mill is going to create lifting forces, which on sheet metal is a big problem. So this is an excellent use case for left-hand helix cutters. You may have seen those on the supplier websites and wondered what they're for. Well, they create downward forces as they cut instead of upwards, which is normally not what you want because they don't clear chips very well, but for something like cutting sheet metal, they're perfect. It's also likely that my feed rate was too high, so the end mill probably couldn't keep up, especially running too slow as it was. So I switched to a 1/8 end mill and adjusted my dimensions so that I could still get a good number of parts out of the stock here. The edge is pretty furry when it comes off of the mill, but a quick deburr and you can see what a nice result you get. So milling is actually quite a good way to make very nice pieces of sheet metal when you need really good edges if you don't have proper sheet metal tools. Now I'm going to anneal the strip here to get ready for forming it. I'm just making one boiler band first to see if my overall design here is going to work because I'm making this up as I go along. I don't have a proper sheet metal slip roll, so here's a method I learned from Myford Boy. You put the stock on a soft surface and just roll it with a piece of scrap like that. And, well, he's a lot better at this than I am, but this does actually work if you do it right. And a little test fit there, and it looks like this is going to work. So I'm going to have to bridge the gap there because these strips are about an inch shorter than I would like them to be, but I think I can do that. So now I put in a larger parallel so I can make the next strip down the line here. And I'm doing 2 strips at each setting because I need to cut up 2 of those pieces that I showed earlier. Now once all those strips are made, now I need to make little blocks for fixing the ends, much like the blocks that you saw for the boiler bands. So I made up a bunch of these little cubes with a clearance hole drilled through them, and I'm going to try silver soldering those onto one of the bands here. So I'm using my jeweler's fixture plate again, and this seemed to go okay. Now to bridge that 1-inch gap that I talked about, I'm going to make some extended studs that are going to get silver solder to the other end of the band. So over to the lathe, I've got some 1/8 inch brass bar stock here, and I'm just going to turn down the end a little bit because I want to put some small threads on the end. So I'll face the end as is tradition. And then I'm just going to skim the surface down here a little bit because I'm going to put a 440 thread on there. In hindsight, if I just made these 540, I wouldn't have had to do the turning, but, you know, live and learn. And the threads went on there just fine. This brass is actually not 360 free machining brass, the kind I usually use. This is some kind of harder brass, and it's a little bit fussy to machine here, as I've learned. This is what you get buying things on eBay. You don't always know what you're getting. Sometimes the listings aren't right, or sometimes the sellers don't know what they have. So I soldered that onto the band, and then I also annealed the stud there as well so that I could bend it around the last little bit of the shape of the boiler. And that looks like it's going to work. A little test fit here, and it looks like these are going to work. However, I just realized at this moment that there isn't enough room for the nut or a socket to turn the nut. Those little blocks are too short. So I made instead 6 new blocks that are taller so that there will be room for the nut and the wrench on there. Now I've been having trouble silver soldering these tiny parts because the wind of the torch blows them around. So I thought I'd go check out what jewelers do, because jewelry makers face this problem all the time. And one of their solutions is clay. They use regular air dry clay for fixturing small parts for silver soldering. So I thought I'd give this a try. So I made a little block there that's the right shape for holding my little cube, and I let that dry, and then I set it on the block there with a little bit of backing to hold it in place with some wetter clay, and then I set the block in there. And it worked in the sense that it did hold the block in place, but the clay made a terrible mess. Now I had tested this to make sure it could handle the heat, and it seemed to do just fine. It scorched, but it didn't catch fire or anything. However, it created this flaky dust of clay in the air, and it smelled really bad. You can see it smoking quite a bit there. So this worked, but not great. I guess the jewelers don't use as big a torch as I'm using here. And you can see that I didn't get a super great joint there. The penetration of the silver solder is not good. So I tried a different technique for the other blocks, but let's see how this one fits on there. And yeah, that's good. That solved my nut clearance problem. So the basic design is sound. I can make 5 more of these bands now, and I experimented with different setups for silver soldering, and this is what ended up working the best, was placing the block up against the backstop there so the torch can't blow it away, and then I'm placing the silver solder in the joint ahead of time. Sometimes I find it easier to touch the silver solder in when it's hot. Other times it's easier to preload the solder in there. And the solder, those little solder pieces are positioned such that the torch will kind of blow them into the joint. And that worked really well. I got clean, easy joints by doing that. So there's all 6 bands ready for forming. Now for final forming, I gave up on the rolling method and just grabbed a big piece of stock and just bent them around there by hand, and that seemed to work fine. Now I need some nuts. I'm going to make them out of brass so that there's no dissimilar metal situation there underneath. And so this, I just made all 6 of these at once by drilling and tapping all the way through some stock, and then parting them off, chamfering the back and front of each one as I go. You've seen me make piles of nuts before. Now the main trick here for catching them is to use the scriber, which works perfectly. A little deburring, the nuts are done, and now I have 6 complete boiler bands. That was a very normal amount of work here in the imaginary universe where commercial boiler banding doesn't exist. Now on to the wood finishing. I'm thinning tung oil with 50% thinner here. I went back and forth a lot on how to finish this wood. I considered all kinds of different oils and polyurethanes and different things. So something like a polyurethane was pretty much ruled out immediately because they really can't take much heat. So it was down to the oils. I considered some food oils like walnut or canola or olive oil. People do use those for finishing furniture, and I have heard of people using them on boiler lagging. I was a bit concerned that there might be an issue with those going rancid, but they do have a very high smoke point, so that seemed like a good thing. In the end, I went with the tung oil, mostly because I had it on hand, and the data sheet for this stuff says it doesn't start to break down until around 400 degrees, so it should work just fine. And it looks great, and it smells amazing. I really love the smell of tung oil. Now to fit the boiler bands, I experimented with their positions a little bit to find a place that would hold all the little pieces and kind of looked like a nice even distribution. I made two of the bands wider to put on the ends because the ends need a little more support, and that's where the really small pieces are as well. You can see that the bands tighten up nicely there with the little brass nuts. I did find that in a few places the addition of the wood made the diameter larger than in other places because of how the wood sits near the joints and such, so I had to thin down my blocks in a couple of instances because the studs that I made were too short to reach all the way through. So other than those modifications, this worked pretty well. You can see the final result here. I am really pleased with how that looks. Part of what made this approach work, of course, is that the lagging doesn't go all the way underneath. I didn't bother lagging the lower inch there because there's a lot of fittings down there. It was going to be really difficult to get it fitted. You can't see it down there anyway, and most of the heat is going up. Now, even though this is just straight wood, there's no insulation blanket underneath, as is often done with lagging. I have to say this made quite a remarkable difference. I would say this thing steams up about 40% faster than it used to, and when it's running, the outside is no longer instantly scalding. It's still too hot to leave your hand sitting on it, but it doesn't immediately scald you when you get anywhere near it. So it's definitely an improvement on safety and performance, and it certainly looks better. I think there's no debate about that. So I'm very pleased with this result. This was definitely worth doing. I hope you enjoyed this little process. If you like these videos, throw me a little love on Patreon maybe, and I will see you next time.